Most planets are shrouded in atmospheres made out of a mixture of different gases. Giant planets like Jupiter have very thick atmospheres made of hydrogen and helium, with small addition of molecules, mostly methane and ammonia. Rocky, small planets, such as Earth, have much thinner atmospheres that are composed of heavier gases like nitrogen, carbon dioxide and water vapor. The Earth has an exceptionally high amount of oxygen in the atmosphere that was generated by life on the planet. Some molecules in the atmosphere are greenhouse gases. This means they are good at trapping heat from the sun and warming up the atmosphere and the planet's surface below it. One good example of such a molecule is carbon dioxide. Imagine for a moment that the planet doesn't have an atmosphere. After radiation from the sun passes down to the surface, some of it is absorbed by the planet's surface and some of it is reflected. Remember that most of this radiation is composed of visible wavelengths, which we color-coded in the image with yellow arrows. So, what determines how much radiation is reflected and how much is absorbed? It's reflectivity of the planet, or what scientists call the albedo. Albedo depends on the nature of the planet's surface. If the surface appeared light in color, it means that it will generally have a high reflectivity or albedo. Darker surfaces are less reflective. So, for example, a snowy surface will have a high albedo, and a deep ocean surface, deserts or mountains, will have a low albedo. Radiation absorbed by a planet warms it up. But the planet has to cool as well, so its temperature stays in balance if the amount of radiation from the sun doesn't change in the long term. The heat energy of the planet is re-radiated in space at infrared wavelengths. We have color-coded infrared with red arrows. Now let's add the atmosphere to this picture. Radiation from the sun passes to the surface again. Some of it will be reflected and some of it will be absorbed as before. Now, however, some of the radiation may also be reflected from the clouds in the atmosphere. Absorbed radiation will be re-emitted as infrared radiation. If there were no greenhouse gases in the atmosphere, this radiation would disperse in space easily. But let's now add some greenhouse gases into the atmosphere. We will make this look like a shell on top of the rest of the atmosphere, but remember that this is just a cartoon representation. In reality, the greenhouse gases are mixed well throughout the atmosphere. In the Earth's atmosphere, the most important greenhouse gases are water vapor and carbon dioxide. Now, the greenhouse gas absorbs the infrared emission from the ground and stops it from escaping easily in space. Some of this infrared radiation is trapped and re-emitted by the greenhouse molecules. It's scattered in the atmosphere but also absorbed again by the surface of the planet. In effect, this radiation hangs around for a long time, keeping the planet and its atmosphere warmer than if the atmosphere with greenhouse gases wasn't there.